Welcome back to physics class. Okay, now we are in the chapter of wave optics. Okay, in the last class we had discussed the coherent sources and incoherent sources. What is a coherent source? Coherent source that always produce bright images. Even interference can be obtained on a screen. If there is no interference is obtained on a screen, then such a sources are called incoherent sources. Example for the coherent source is laser light. Because from a laser light, the waves are in same phase. In a laser, all the waves are in same phase. Whereas if the light waves emitted by the source are not in the same phase and in having a different amplitude, such sources are called incoherent sources. Okay. And related to the coherent source and the incoherent sources, how to find the constructive wavefront and how to find the destructive wavefront. Okay, that also we have discussed. And from that we have discussed the interference for the constructive wavefront and destructive wavefront, because in resultant displacement of the destructive wavefront is 0, whereas the constructive wavefront resultant displacement will be add up. It is like a superposition principle, but both the cases it is add up. But in the case of constructive wavefronts, the crest to crest add and the resultant intensities and amplitude will be higher and the resultant displacement also higher. Whereas in the case of destructive wavefront, there is a destructive interference, the crest and the trough are added, or the trough and the crest are added, so the resultant displacement will be 0, so there is no intensity. So to obtain the maximum intensity, that is to get the positive interference, mostly we will use the coherent sources, because coherent sources that results the constructive interference, so which have a maximum amplitude and maximum intensities and higher the displacement also. Okay, and now we are going to discuss the interference of light waves using Young's double slit experiment. That is Young's double slit experiment, YDSE, which means Young's double slit experiment. So what is the importance of using this experiment? Because in a destructive interference we have a problem. Each waves are in different phase, there is a different angles and different amplitudes. So we need to fix the phase. Okay. So to log the phase, Thomas Young introduced the experiment, that is Young's double slit experiment. Suppose, imagine we have two sodium sources of light. Okay, we have two sodium sources of light. This is source 1, this is another one source, and the two sources are separately illuminate the two slits, slit S1 and slit S2. What is called slit? Slit is nothing but a small opening. Okay, so on an opaque object, if you make a small hole, then it is called a slit. Okay, two slits are placed closer to each other. The distance may be 1 centimeter or less than 1 centimeter or 0.5 centimeter. Imagine the slit S1 and slit S2 are very closer to each other. Then the further waves are originated and all overlap. Finally, on a screen there is no interference, because the main problem here it is incoherent sources, because in incoherent sources each waves have a different amplitudes. So finally there is no locking in the phase, so no interference are made. So to avoid this, Thomas Young conducted an experiment, that is double slit experiment, using two slits, two consecutive slits which are placed very closer to each other from the actual source. Then he obtained the interference on a screen. Okay, look at the diagram. This is a sodium, monochromatic sodium light. Okay, from the sodium that emits a light, then the light is allowed to pass through a small slit. So this is a bright source. Okay, and then the circular wavefronts are emanated from the sources, which is traveling towards the slit. This is slit S1, this is a slit S2. So from these two slits, listen, read on the diagrams, and this is the screen. Okay. So from the slits, again the secondary waves are originated, which is travel, and from the slit S2 also the waves are started. Then when it was overlapped, Then finally இது ஆக்சுவலா பாத்தீங்கன்னா உங்களோட டாப் வியூ. பட் சைடு வியூ எப்படி இருக்குன்னா இப்படி இருக்கும். This is a side view of the wave. So இது crest, இது trough, இது crest, trough. So இது crest, அடுத்து வர trough, அடுத்து crest, trough. So crest எல்லாம் நான் bold போட்றேன். These are all crest. These are all crest. So இப்போ crest to crest செய்து நமக்கு ஒரு bright line கிடைக்கும். Crest and crest will get one bright line. Again trough and trough will get there is a crest and the trough will get a dark line. This is a dark line. Again trough and trough, it's a bright line. Then trough crest, it's a dark line. And then crest and crest, it's a bright line. So we'll obtain on a screen a consecutive bright line, a dark line, then bright line, dark line. So this is called an interference. So the interference fringes are obtained on a screen. Okay. So to obtain the interference, Thomas Young did one thing. He fixed the phase. So phase locking is an important made by Thomas Young. So he fixed the phase, that is phase lock. Phase locking is an important thing in this experiment. Okay. So from this experiment, our aim is to find the path difference and then to find the what is a fringe width. What is a fringe? We are going to discuss. Not a fringe. Okay, fringe and then fringe width. Okay. So we are going to calculate mainly the path difference, then the what is it? Resultant path difference and then fringe width. Okay. So before going to the path difference from the experiment, we'll read out the diagram. This is the actual source. So this bright source are illuminating a single slit. From the single slit, the bright light is coming out. Okay, this is a bright line path. Then on the path of the bright light, two small slits are placed very close to each other. Slit S1 and slit S2. The two small slits which are placed very close to each other at a distance D. So D is the distance between the two slits. Then the interference which are made on the screen. Here G and G dash is the screen on which the interference is made. So the screen is located away from the two slits. That is at a distance of capital D. What is the capital D? From the screen, the two slits are located at a distance of D. Okay. So this is the original mean position O. Okay. So from the original mean position at a point P, we are going to determine the interference. So the point P is located from S, this is that. Similarly, S2 is located from P. So from the original source path, the interference path is located at the distance of X. So from the diagram, S1, S2 which is equal to small d and OP which is equal to X. But the condition is, note the important conditions, the distance between the two slits to the screen is very larger compared to the distance between the two slits and the distance between the point in which the interference made from this actual axis. Okay, so the distance between the two slits is much smaller than the actual distance between the slits to the screen. This is one condition, and another one is the distance of the point on a screen in which the interference is determined is much less than the actual distance between the slits and the screen. So X also much smaller than the actual distance between the slits and the screen. Okay, புரியுதுங்களா? அப்பனா மீனிங் என்னன்னா இந்த ரெண்டு ஸ்லிட்டுக்கான டிஸ்டன்ஸ் வந்து சப்போஸ் எவ்வளவு இருக்குன்னா 0.5 cm இருக்கு. அப்போ அதனோட ஒரிஜினல் சோர்ஸோட ஆக்சிஸ்ல இருந்து நம்ம Pங்கிற பாயிண்ட்ல இன்டர்ஃபரன்ஸ் டிட்டர்மைன் பண்றது வந்து 1 cm இருக்கு. அப்படினா இந்த டிஸ்டன்ஸ் வந்து 1 மீட்டரா இருக்கலாம். So this 1 meter is greater than 0.5 cm. Also this 1 meter is greater than 1 centimeter. Okay, so this is the conditions we are going to use. Okay, so actual pathukku parallel or line draw பண்ணுங்க. It meets at a point A. Similarly, from the second slit you draw a parallel line to the screen. It meets at a point B. So the distance between the two slits is small d. From the original path, this point A2O is D by 2. அப்போ இந்த distance என்னவா இருக்கும்? Equidistance only, no? D by 2. So D by 2 plus D by 2 is equal to D. Okay, don't forget. Okay. So நமக்கு இப்போ என்ன வேணும்? Our aim is to find the path difference and then to find the fringe width. Okay, first we are going to find the path difference. Already we know the path difference. What is the path difference? Path difference, this is that from the two slits, the point P, how much distance it is located. So in the previous class we have seen for a constructive interference and destructive interference. Okay, that is for a bright lines and dark lines. Okay, so this is the original difference, that is a path difference. But we want using Pythagoras theorem. Okay, look at that. The first triangle is we want to find S2P and S1P. What does the Pythagoras theorem says? Pythagoras theorem is nothing but S1P square and also S2P square. We want to find it separately. So S1P, take the triangle, right angle triangle, S2PB. What is the triangle? First S1P. We want to determine S1P. So the triangle is S1AP. S1AP. So in this right angle triangle, S1P square is equal to S1A square plus AP square. So what is the S1A square? S1A square is parallel to D, so D square. And then AP square is nothing but from X, if you subtract D by 2, you will get AB. So AP is nothing but from the X, if you subtract D by 2, you will get AP. So this is S1P square. And then next triangle, right angle triangle is S2PB. What is the next triangle? S2BP. So in this right angle triangle, S2P square is equal to S2B square plus PB square. Okay. What is the S2B square? S2B is nothing but D. So S2B square is D square and BP, this is a point, no? BP, this is a point. BP is equal to X and this is D by 2. So adding these two lengths, OP plus OP, OP plus OB or OB plus OP is nothing but, what is it? BP. So BP is the sum of OP plus OB. So we need to add this both. Okay. Then substitute this value in the path difference equations. Substituting these two values in path difference equations. What is the path difference? Yes, square the both equation and then substitute. So square equations. I will change one thing. Yes, this is wrong. This is nothing but 3 square minus 2 square. So 3 square minus 2 square we will get 3 square minus 2 square left hand side. Similarly right hand side also 3 square minus 2 square. So 3 square minus 2 square. So expand it. This is a minus b whole square formula, no? So by a minus b whole square formula expand பண்ண என்ன கிடைக்கும்? So அதை வந்து simplify பண்ணி டைரக்டா உங்களுக்கு ஆன்சர் கொண்டு வந்திருக்கேன். இங்க போடுற பாருங்க. So இப்போ என்ன கிடைக்கும்னா d square plus x square plus d square by 4 minus 2xd by 2. அடுத்து minus d square அப்படியே வந்துருச்சு. அடுத்தது again minus தான் வரும். இது a plus b whole square form இருக்கா? So minus x square minus d square by 4 and then what do you get? S2p. Yes. So after simplifications, the plus value minus value get cancelled away. Then we will get xd. Okay. Then you will get 2xd because this also cancel out. And here plus 2xd by 2 cancel. So d square minus d square plus x square minus x square plus d square by 4 minus d square 4. But this ரெண்டுமே 2 தான் cancel ஆகும். அப்ப xd plus xd is nothing but 2xd. Okay. So அந்த simplification தான் டைரக்டா போட்டாச்சு. So this formula looks like a square minus b square. அதை expand பண்ணா என்ன கிடைக்கும்? a plus b into a minus b. So this looks like the left hand side of this terms looks like a plus b into a minus b. So expand பண்ணா s2p plus s1p into s2p minus s1p. But this term, the plus terms, we are bringing to the right hand side, that become a denominator. But this denominator become 2d. ஏற்கனவே நான் condition சொல்லிருக்கேன். What is the conditions? See, the same conditions are written already. What is the conditions? The distance of separation between the two slits to the screen is much larger than the distance between the two slits, as well as the point from the original axis in which the interference is found. So, the denominator becomes 2D. So, that is, in a simpler solana, if on the S1 S2 points are located very close to each other. This is S1, this is S2. So, this is a screen on which the point P is determined. So, இங்கிருந்து இது measure பண்ணக்கூடிய டிஸ்டன்ஸோ இங்கிருந்து measure பண்ணக்கூடிய டிஸ்டன்ஸோ almost இதுக்கு ஈக்குவலா தான் இருக்கும். So, இது 100 சென்டிமீட்டர்னா இதுமே approximately 100.1 இது 100.01 இது மாதிரி தான் இருக்கும். So, அப்ப ரெண்டுமே denominator add பண்ண என்ன ஆகும்? This also D, this also D. So, D plus C become 2D. So, substitute in this fourth equation, the denominator value is 2D. After substituting 2 cancel, so xd by D. So, this is the path difference in this case. Okay, for a constructive interference. And final conclusion is made from Thomas Young's experimenters. The light waves emanating from the coherent source. Yes, because we obtained the original interference on a screen, since such a sources are called coherent sources. If no interference fringes are captured on a screen, then the sources are called incoherent source that we had discussed in last class. So, namakku screen la interference capture pannirukkom. So, the interference are made on a screen. Such sources are called coherent sources that produce the consecutive dark bright lines. See, this is a dark, this is a bright, then dark lines, bright lines, dark, bright, dark, bright, dark, bright. So, அடுத்து நமக்கு ஒரு black line to white light to then black white அப்படியே மாறி மாறி வந்துட்டே இருக்கு. So, this is obtained on a screen which is placed some distance away from the slits. So, on the screen வந்து slits இருந்து கொஞ்சம் தூரம் தள்ளி இருக்கணும். So, to the maximum distance நமக்கு எக்ஸாம்பிளுக்கு 100 cm எடுத்துருக்கோம். And the distance between the two slits may be 0.5 cm, and the point in which the distance the interference is measured from the axis is 1 cm. Okay. So, this is the conclusions made from Thomas Young's experiments. The continuity still we have. We need to find the fringe width. Before knowing the fringe width, what is the fringe pattern? Okay. The continuity of this experiment, fringe pattern. So, what is the fringe pattern? Just now I said the alternative dark bands and the bright bands are called fringe pattern. Fringe pattern. Fringe pattern is nothing but an alternate dark bright bands, dark bands bright bands. Okay, so first we are going to see for a bright band. Bright bands. So, to get the bright bands interference, that must be a constructive interference. நமக்கு bright lines வேணும்னா அங்க கண்டிப்பா என்ன இருக்கு? crust to crust இல்ல trough to trough ஃபார்ம் ஆயிருக்கு. So, ஏற்கனவே நான் சொன்ன மாதிரி வர waves-ல this is a source emanating waves. Here the slits are made which is placed closer to each other. Then from the slits other waves are emanated. Then this is on a screen. அப்ப ஸ்கிரீன்ல பார்த்தோம்னா நமக்கு first crust அடுத்து இருக்க இந்த வேவோட crust இது ஜாயின் ஆனா நமக்கு ஒரு bright lines கிடைக்கும். Then trough to trough another one bright lines, but crust to trough it's a dark line. Okay, so அப்போ ஒரு bright lineம் இன்னொரு bright lineம் சேர்ந்தா நமக்கு ரொம்ப பெரிய bright line கிடைக்கும். Then one dark line another one dark line இன்னொரு dark line கிடைக்கும். But crust and the trough joined together, the resultant is 0. So, for 0 resultant, we'll get only the dark, and for a bright crust or a bright dark, we'll get the bright lines. Okay. So, this is Young's experiment. அப்போ இங்க யூஸ் பண்ணிருக்க இந்த source is called coherent source. அப்ப நமக்கு bright bands கிடைக்கணும்னாவே that must be a constructive interference. Okay, so as we know already in last class we have discussed, so for a bright band to obtain that must be a constructive interference, and in this case the position is maximum intensity, constructive interference, and the position of maximum intensity. Okay, so what is the path difference on this case? So the path difference is n lambda, but here we found the path differences. Yes, here we have found the path difference xd by d. What is the path difference for a constructive interference? But we know the path differences. What is the path difference? xd by d. So compare the both equations. Left hand sides are equal, automatically right hand sides are equal. Therefore xd by d is equal to n lambda, or x is equal to n lambda by d. So this is for what? Yes, n lambda, something I changed, n lambda d, sorry, x d by d is equal to n lambda. So x is equal to n lambda, the denominator terms comes to right hand side, n lambda d by d. So this is the, what is it? This is the position for nth bright band. So this is nothing but position of nth bright band. This is the position of nth bright band. So for a central bright band, n is equal to 0. So xn is also 0. So நமக்கு இதுதான் center, no? So இப்படி தான் கிடைச்சிருக்கும். So the interference. So இது original source, இது slit S1, இது slit S2, அப்ப central bright band இதுதான் அது. So அப்ப x is equal to 0. Okay, so xn is nothing but position of nth bright band. அப்ப அந்த ஆர்டர் மாறிட்டே இருக்கும், first second third ஆன. For one complete wave அது எப்படி இருக்கும்? So we'll see the graphical representations in the upcoming topics. Okay, so this equation says the position of nth bright band. For a central bright, we'll write that too. For a central bright band, n is equal to 0. Therefore xn also 0. Okay. Similarly, we can find the dark bright band. How? See, next one is dark bright band. So dark bright band means mostly it is not a constructive, it is a destructive interference, and the position of maximum, not maximum, minimum intensity, position of minimum intensity, and the path difference. What would be the path difference? It's not n lambda by d, n plus 1 by 2 into lambda. Yes, and here there is no change, it remains same, xd by d. Then compare the both the equations, what you will get? Comparing both the equations, you will obtain, see, path difference, and this is also path difference, both are equal in left hand side. So equating the right hand side, xd by d is equal to n plus 1 by 2 into lambda. Okay, so x is equal to n plus 1 by 2 into lambda d by d. Okay, so this is the position for nth dark band. So this is a position for nth dark band. Okay, similarly in the graphical presentations we are going to discuss. So அப்ப இது வரைக்கும் நம்ம பார்த்திருக்கிறது path difference, and then the fringe pattern எப்படி இருக்குன்னு பார்த்தோம். அது bright band க்கு எப்படி இருக்கும், dark band க்கு எப்படி இருக்கும். Okay, The next one is graphical representation. So in a graphical representation, see, the band looks like this. This is a interference band. Dark band, bright band, again dark, bright, dark, bright, dark, bright, dark, and then bright, dark, bright. So dark, bright. So consecutive dark and bright bands are obtained. Then the graph is plotted between the intensity and the path difference. The graph is plotted between intensity and path difference. So, the waves the waves are emanated from this, and then this 0 at mean positions. At mean positions x is equal to 0. Adukaprom emanate agudhu. It's emanated from here and it goes up. It's a dark. Again to increase to bright band, and then to 0, and then to bright band. Okay, then in this side pathina dark, and then bright, dark, bright, it's a dark, it's a bright, and dark. So இது எல்லாமே bright band கானது. இது எல்லாமே bright band கானது. So இது எல்லாமே dark band கானது. புரியுதுங்களா? So இது எல்லாமே dark band. இதுக்குள்ள இருக்கிறது எல்லாமே all dark band. So அப்ப என்ன பாத்தீங்கன்னா ஒரு complete wave நம்ம எப்படி represent பண்ணுவோம்? So அப்போ the graph is plotted between the, what is it? Yes, intensity and the path difference. Okay, so this is 0. The wave emanated from here and finished one cycle. So this is 1 lambda. Again it originated, the second wave originated from here, finished here. So this is 2 lambda. Similarly this is 3 lambda. It goes on. And in the left hand side, this is 1 lambda, this is 2 lambda, and this is 3 lambda, which means lambda means, what is the wavelength? What is the wavelength? Wave inga emanate aayirukku, inga emanate aayi inga mudinjirukku, mudinji thirumba inga poirukku. This is one complete wave, or we may say iddiyum poduvom, this is one complete wave. Okay, both also same only. So we'll write like this itself. So this is a single wavelength. Idanoda difference evlo irukku? 1 lambda minus 0, it's 1 lambda, no? So the lambda which is equal to 2 pi. Similarly for 2 lambda it is 4 pi. 3 lambda it is 6 pi. So it's a 2 pi, 4 pi, 6 pi. It goes on like this. Okay. So from this graph, the central bright bands having maximum intensity. Central bright band that have maximum intensity. Maximum intensity. Okay, because path difference is 0, and also the phase. This is a phase also. Phase illa inga da 0 degree. Phase 0 degree. Path difference also 0. Okay. But dark banding irukuduna, this is a dark band. In the line irukliya. So this is a dark band. For a dark band, n is equal to 0, and path difference is equal to, what is the path difference? N plus 1 by 2 lambda, no? Which is equal to, n is equal to 0 and enna vandirukum 0 plus lambda by 2. So which is equal to lambda by 2. So this is the path difference, as well as the phase is right side on the plus 5, left side on that is minus 5. 180 degree, it's a straight line along the axis. Okay, புரிஞ்சிருச்சா? So graphical representation இதான் நம்மளோட original interference pattern. அந்த original interference pattern க்கு இப்ப நம்ம graph plot பண்ண போறோம். ரெண்டு டேட்டாவுக்கு, ஒன்னு intensity, இன்னொன்னு path difference. So intensity is taken in y axis, path difference is taken in x axis. So இப்போ இந்த interference பாத்தீங்கன்னா இந்த ஷேட் பண்ணிருக்கிறது எல்லாமே bright lines, மீதி இருக்கிறது எல்லாமே dark lines. So இது எல்லாமே dark, இதெல்லாம் bright lines. புரிஞ்சுதா? ஓகே. சோ இப்போ நமக்கு கிராஃப்ல பார்த்தோம்னா நமக்கு என்ன இருக்கு, அது மீன் பொசிஷன் இங்க இருந்து ஆரிஜினேட் ஆயிருக்கு. சோ அப்போ மேக்ஸிமம்ல இருக்கா, அப்ப x is equal to 0ல இன்டென்சிட்டி எப்படி இருக்கு, மேக்ஸிமமா இருக்கு. சோ this is the point is maximum intensity. அதுக்கப்புறம் என்ன ஆகுது, இப்படியே போயிட்டே இருக்கு. சோ இது ஒரு வேவ் முடிஞ்சிருச்சு. ஆஃப்டர் கம்ப்ளீட் 0 ஒன் வேவ் முடிஞ்சுது. அப்ப இதனோட ஆங்கிள் எவ்வளவா இருக்கும், இட்ஸ் a 2π 360. தென் அடுத்த வேவ் இதே மாதிரியே போயிட்டே இருக்கும். இது ரைட் ஹேண்ட் சைடுல, அப்ப இந்த பக்கம் போறது எல்லாமே +5 ஆர்டர்ல போயிட்டு இருக்கும், இந்த பக்கம் போறது எல்லாமே -5 ஆர்டர்ல போகும். சோ அப்ப இதுல பாத்தீங்கன்னா நமக்கு ரெண்டு லைன்ஸ் இருக்கு, பிரைட் லைன்ஸ் இருக்கு, டார்க் லைன்ஸ் இருக்கு. பட் ஃபர்ஸ்ட் இருக்க சென்ட்ரல் பிரைட் பேண்ட்ல பாத்தீங்கன்னா there have maximum intensity. அப்ப path difference இல்ல, அதே மீன் பொசிஷன்லயே தான் இருக்கு. அப்ப path difference வந்து 0, s2p - s1p ஒரே பாயிண்ட்ல இருக்கனால 0. சோ அப்ப ஃபேஸும் இல்ல. பட் அடுத்து ஒரு டார்க் பேண்டுக்கு பாருங்க. சோ இப்ப இந்த கீழ இருக்கிறது எல்லாமே டார்க் பேண்ட். சோ இப்ப டார்க் பேண்டுக்கும் அதே ஆக்சிஸ்ல இருக்க, அப்ப n is equal to 0. what is the path difference? Path difference for a dark line is n plus 1 lambda, n plus 1 by 2 lambda. அப்ப n 0வா இருந்ததுன்னா 0 plus 1 by 2 lambda is lambda by 2. அப்போ lambdaங்கிறது 2π னா lambda by 2 எவ்வளோ, 2π by 2 is equal to π. அது ரைட் சைடா இருந்தா +5, லெஃப்ட் சைடா இருந்தா -5. so it is plus or minus 5. so இப்படி தான் நமக்கு என்ன ஆயிட்டே போகும், அதனோட ஃபேஸ் வேரி ஆயிட்டே போகும். சோ அடுத்து நம்ம பார்க்க போறது fringe width. okay, so we'll continue the fringe width. look at this, next one is fringe width. what is the fringe width? நம்ம fringe pattern என்னன்னு பார்த்தோம். அடுத்து fringe width. width தான் it's nothing but அகலம், நம்ம அகலம்னு சொல்லணும்னா fringe width. so fringe width is nothing but distance between two consecutive, நம்ம இந்த டயகிராம் அடிச்சாச்சு, distance between two consecutive bright bands and dark bands. what is the fringe width? it is the distance between two consecutive dark bright bands. so இதுல ரெண்டு இருக்கு, fringe widthல ரெண்டு இருக்கு. ஒன்னு linear fringe width, இன்னொன்னு angular fringe width. linear fringe width and another one is angular fringe width. first linear fringe width என்னன்னு பார்ப்போம். so what is the linear fringe width? so it is the distance between the, yes, already we have seen the distance between the two consecutive bright and dark bands are called fringe width. the linear fringe width, it is denoted as the symbol beta. so xn plus 1 minus xn. okay, so அப்ப ரெண்டுக்கு டிஃபரன்ஸ் எடுத்தா நமக்கு என்ன கிடைக்கும்? what is it, xn plus 1? already we have discussed. okay, n lambda d by d plus lambda d by d, இது xn plus 1 க்கு, minus xn சேம் தான், n lambda d by d. அப்ப ரெண்டுமே கேன்சல் ஆயிரும். அப்ப ஃபைனலா நமக்கு என்ன கிடைச்சிருக்கு, lambda d by d. so for a linear fringe width it is lambda d by d. okay, so this is the linear fringe width. next பார்க்க போறது angular fringe width. what is the angular fringe width? angular fringe width is nothing but an angle subtended by a bright and dark fringe at the center of two slits. இப்போ நமக்கு ரெண்டு slits இருக்கு, slit S1, slit S2. Pங்கிற பாயிண்ட் ஸ்கிரீன்ல இங்க இருக்கு. ஓகேவா? அப்ப பார்த்தா நமக்கு ஸ்கிரீன்ல எப்படி கிடைக்கும், ஒரு டார்க் லைன், பிரைட் லைன், இது அதனோட மீன் பொசிஷனா, இதை முதல்ல போட்டுருவோம். ஓகே, அப்ப இதுவே சென்ட்ரல் பிரைட் பேண்ட், அடுத்து டார்க், அடுத்து பிரைட், அடுத்து டார்க், அடுத்து பிரைட், அடுத்து டார்க், அது பிரைட். So இதான் interference fringes screenல கிடைச்சிருக்கிறது G dash. Okay, இது அதனோட center O. So it is an angle subtended by a bright and dark band fringe at the center of two slits. So ரெண்டு slitsல இருந்து எவ்வளவு தூரத்துல கிடைச்சிருக்கு angle subtended at the center. இந்த ரெண்டு ஸ்லிட்டோட சென்டர் இதுவா, அப்ப ரெண்டு ஸ்லிட்டோட சென்டர்ல இருந்து அந்த ஒரு பிரைட் இல்ல டார்க் இதுக்கு எவ்வளவு ஆங்கிள் கிடைச்சிருக்குன்னு. It is an angle subtended. It is an angle subtended. Okay, it is an angle subtended by a bright and dark fringe at the center of two slits. ரெண்டு ஸ்லிட்டோட சென்டர்ல இருந்து எவ்வளவு ஆங்கிள்ல கிடைச்சிருக்கோ that is called angular fringe width. So already we know here this is a screen G and G dash. Okay, this is a bright line. Suppose we assume this is a bright line, this is a central bright line, then அடுத்து வரக்கூடிய bright line, then அடுத்து xn plus 1, அடுத்து இதே மாதிரி xn plus 2, xn plus 3, it goes on for bright lines. Okay, அதே மாதிரி இது dark line, இது xn ஓட dark line, இது xn plus 1 ஓட dark line. So அதே மாதிரி இது xn plus 2, then xn plus 3 ஓட dark lines இப்படியே போயிட்டே இருக்கும். So அப்ப இங்க நமக்கு same formula. This is also beta is equal to xn plus 1 minus xn. The same value will get lambda d by d. But நமக்கு என்ன வேணும், இந்த இதே டயக்ராம் என்ன மாடிஃபை பண்ணி போடலாம். ரெண்டு ஸ்லிட்டும் ரொம்ப placed closer to each other. அந்த ஸ்லிட்டோட சென்டர்ல இருந்து நமக்கு என்ன வேவ்ஸ் கிடைக்குதா, வேவ்ஸ் எமினேட் ஆயிட்டு மறுபடியும் ஆரிஜினேட் ஆகி இப்படிதான் வருது. ஸோ அப்போ இங்க அது கிரியேட் பண்ற ஆங்கிள் இது S1, இது S2, இது அதனோட சென்டர். புரியுதா? ஸோ அப்போ Pங்கிற பாயிண்ட் இங்க தானே இருக்கும். ஸோ அந்த Pங்கிற பாயிண்ட்ல இருந்து ரெண்டு ஸ்லிட்டோட சென்டர் வரைக்கும் அதை மேக் பண்ற ஆங்கிள் தான் என்னது, angular fringe width. What is the angular fringe width? It is an angle subtended by a bright and a dark fringe at the center of two slits. ரெண்டு ஸ்லிட்டோட சென்டர்ல இருந்து அந்த bright line dark line fringeோட எவ்வளவு ஆங்கிள் மேக் பண்ணுது அதுதான் angular fringe width. So from this figure we can find this is a distance d. This does not change. Distance between the two slits to the interference point does not change. So from this figure theta is equal to beta by d. It is a ratio between what is it, fringe width to the distance between the slits to screen G and G dash. So substitute the value. Already we know beta is lambda d by d, lambda d by small d, and already we have capital D. So the distance cancel. Therefore angular fringe width theta is equal to lambda by d. This is the angle subtended between the center of two slits to the bright and dark line fringes on the screen. Okay. So in your refer your bookல பாத்தீங்கன்னா உங்களுக்கு அந்த இமேஜ் டீடைலா கொடுத்திருப்பாங்க. So அதுல எப்படி interference fringes இருக்கு, அதுல bright line dark lines எப்படி இருக்குன்னு கொடுத்திருப்பாங்க. So the conclusions will continue in the next class. Thank you. Continuity will continue. So there are two type of fringe width. One is the linear fringe width, another one is angular fringe width. What is the angular fringe width? Angular fringe width is nothing but it is an angle subtended from the bright line bandwidth to the center of the two slits. ரெண்டு ஸ்லிட்டோட சென்டர்ல இருந்து நமக்கு அந்த ரெண்டு bright lines ஒரு successive bright line white lines வருது இல்லையா, ஸோ அதனோட பேண்டுக்கு இருக்க angles. So already we know the linear bandwidth, it is lambda d by d. Okay, now we want to find the angular bandwidth, that is theta. So how to determine angular bandwidth? Listen. So this is how the angular bandwidth can be explained. So it is an angle subtended by the center of two slits to the consecutive bright and a dark band. Okay, இப்போ this diagram can be modified. This is a screen. So on a screen we obtain the central bright band and then dark band, then one bright band, then bright dark, bright, then dark, then another bright. So it goes like this. Okay, so அப்போ இதுல இருந்து நமக்கு தெரியும். So in the distance இதுதான bandwidth, so it's a beta. This is equal to beta. This distance is equal to beta, and this distance is equal to d. So angle theta is equal to, it is a tan theta. We'll use tan theta. Why we use tan theta? I'll say. So tan theta is equal to opposite by adjacent. Since here theta is very small, because రెండు slit may place very closer to each other, approximately 1 millimeter or less than 1 millimeter. ரெண்டு slit க்கு நடுவாண்ட இருக்க space பார்த்தீங்கன்னா ரொம்ப less space, but screen is kept far away from the center of the slits. Okay, so approximately it's very less. So அப்ப நம்ம மெஷர் பண்ணக்கூடிய இந்த distance மாறாது. So the denominator ஆனால நம்ம 2d எடுத்துக்கிட்டோம் இல்லைங்களா later caseல. So S1 ல இருந்து P மெஷர் பண்ற distance, so S2 ல இருந்து P மெஷர் பண்ற distance ஓட sum 2d க்கு ஈக்குவலா இருக்கும். So அதனால நமக்கு இந்த thetaங்கிறது not a large angle, it's very small angle. So what is opposite? It's a beta, and the adjacent is d. So already we know the beta value. It is lambda d by d into d. So dd cancel. Therefore the angle is lambda by d. So this is the angular fringe width. Okay. So now we are going to end this session, not the lessons, this Young's double slit. So the famous scientist, his name is Dennis Gabor. So he won a Nobel Prize in the year 1971 for the principle of holography. You know what is a holography? Hologram, no? For the genuinity of the product, there is a hologram. Even for your 10th certificate and the 12th certificate, the NCERT, the central board hologram is there. If you buy some genuine parts, there is some hologram is there, 3-dimensional holograms. Rainbow color la mari mari theriyum. So that holography. So the holographic principle set by Dennis Gabor in the year 1971. For that he won a Nobel Prize. So he quoted some important points about Thomas Young for his double slit experiment. So what was the statement said by him? Listen. So from his point of view on Young's observations, who's the scientist that? Dennis Gabor. So he quoted on this, and he won a Nobel Prize in the year 1971 for the discovery of the principle of holography. Holography. Still research is going on. So according to him, in the year 1801, Thomas Young, he conducted his first experiment. It's a very simple experiment. He has taken a complete dark room. On a complete dark room, a small slit is kept open. Then the sunlight is allowed to fall through the slit. Then what happens? It gets diffracted. So the circular wavefronts are originated. So from this circular wavefronts are originated. Then on the path of this light through the slit, then he kept a dark barrier. But the dark barrier have a two small opening which is placed very closer. This is the slit S1 and this is a slit S2. Again from here the interference are made. Then finally the final interference which is captured on a screen. So on the screen, this is the screen G and G dash. On the screen at the central lines we have a bright line, another either side a dark line, and again a consecutive bright line and a dark line. So these were found by him. But later இதுக்கப்புறம் அவர் என்ன பண்ணாருன்னா தாமஸ் யங் இன்னும் கொஞ்சம் மாடிஃபை பண்ணாரு. He has taken a spirit lamp. So in a chemistry laboratory we'll use a spirit lamp, no? So this is a spirit lamp. Okay, spirit is nothing but alcoholic substance. Okay, so it's a burning material. So on the bottle cooler on the spirit எடுத்துக்கிட்டு அதை நம்ம லைட் பண்ணோம்னா it will burn like a kerosene lamp. Okay, so இது மேல என்ன பண்ணிட்டாருன்னா he added some salt. He mixed with some salt. Spatula வச்சு salt வச்சு காமிச்சிருக்காரு. அந்த salt என்ன saltனா sodium salt. So when a sodium salt is lighted upon this flame, then the sodium is burnt and it acts as a source that produces an yellow color light. This yellow source is allowed to fall through the same experiment instead of sunlight, which means sunlight is replaced by the sodium light. Okay, then on a screen he observed a consecutive bright and dark lines. Mostly it is dark lines. So from this it is very clear that The first clear proof is given by the Young. It is light added to another light. When a light is added to another light, that can produce, when a light added to another light, that can produce darkness. The main line is darkness. So this is nothing but interference. So this statement only gives about the interference. So when a light is added to another light, that gives the dark lines. So this is from the yellow lamp. Okay. So here also the two slits. This is a single slit and then a double slit. Here one opening, here one opening. So slit S1, S2. So pennache. So namak enna kedachide, maximum light added to the light that can produce the darkness. So this is a clear proof of the wave theory of light. Okay. So idu yaar sonnanga, Dennis Gaber in the year 1971 he won the Nobel Prize for the discovery of the principle of holography. Okay. So now we are going to see a simple example problem. Listen, the problem which is related to the Young's double slit experiment. From Young's double slit experiment, listen. So from Young's double slit experiment, there is a sodium source. Okay, there is a sodium source that is allowed to pass through the two slits, that is S1 and S2, which are spaced at a distance of 1 millimeter. Rendu slit mein 1 millimeter distance la vechirukanga. Then the interference is determined at a point P from the actual axis on a screen. This is a screen G and G dash. So the screen is located from the position of two slits at a distance of 1 meter. Okay, we want to determine the point from which the axis of the central line of the fringe we want to determine. Okay, we know the formula, but here one thing, the two slits are illuminated not by the yellow light. The two slits are illuminated by, the condition is, if the source is blue green light of wavelength 500 nanometer, visible region la 500 nanometer used, then what is the what is the x? So what is the x? Then what is the x? We know the formula. So the displacement x is equal to lambda d by dr. What is the wavelength of the source light used? It is a blue green light. Blue green light of wavelength about 500 nanometer. Okay, so wavelength is 500 nano means 10 to the power minus 9 meter, and the distance between the position of the two slits to the screen is 1 meter. 1 meter divided by, what is the distance between the two slits? It is 1 millimeter. Millimeter means 10 to the power minus 3 meter. Okay. So this is 500 nanometer. So this meter and this meter cancel. We have only 1 meter. So 500 you can write it as 5 into 10 square into 10 to the power minus 9, and minus 3 become numerator. It is plus 3. Then meter is there because this meter is left. So 5 into 10 power 5 minus 9 meter. Therefore 5 into 10 to the power minus 4 meter, or you give 110 to this. What is the value? So we'll get finally how much millimeter? It is 0.05 because denominator only, no. So 5 by 10 into 10 power minus 3 meter. So 5 by 10 is nothing but 0.5. So 0.5 into 10 to the power minus 3. 10 to the power minus 3 is nothing but millimeter. Therefore, from the screen, on a screen, That is, from its mean positions at 0.5 millimeter distance, we will obtain what? The interference. Okay. So remaining will continue next class. Thank you.